All right, welcome to day 11. So some things we got going. You got your regular day 11 homework in our packet, page 68 and 69. You'll be turning that in by 5 a.m. tomorrow. Remember, problem set is also due tomorrow. So by 5 a.m. tomorrow, that has to be turned in. So you should be working on that tonight and finishing it if you haven't done so and turned it in already. Remember, our test is coming up on Friday as well. You have the review sheet already. You can be starting to look at it if you want. You can be coming in to ask questions in office hours and ninth period if you want. But you need to get yourself to the point that if I handed you the review sheet as the test, you could get a 100% on that review sheet easily. If you're not getting yourself to that point, then you're not ready for the test yet. You need to make sure you put in the work ahead of time to get yourself to that point. All right, so we got 3 warm-up questions. I would like you to pause the video in a second here when I'm done talking. See if you can do those 3 questions, and then when you hit play, the 3 different questions will pop up for you to give your answers to those questions. So you can go ahead and pause it now and take a few minutes to do the warm-up right on your warm-up sheet on Wednesday. All right, so heptagon, I gave you a hint there, was 7. So we want to do 7 minus 2 times 180, and that gives us the sum of the interior angles in any polygon. And you should have gotten 900 degrees for that one. In a 42gon, similar idea, but you're doing 42 minus 2 times 180. And that should have been 7,200 degrees. And the angles of a quadrilateral, quad means 4. So if you do 4 minus 2 times 180, that'll give you 360. These are our 4 angles, so we'll do 360 equals each of those added together. Oops, not equals, but plus. So then from there, we should have 8x. If you add your constants, we should have 16. Subtract the 16 over, and that would be 344 equals 8x. Dividing by 8, that would give us 43 equals x. Reread the question, and that's all they wanted us to give, the value of x. All right, moving over to your homework. The first 3, you were just doing like the first 2 in the warm-up. Dodecagon is 12 sides. So you're doing the number of sides minus 2 times 180, and you get those 4 answers there. Next, we got to start out and find our sum of our interior angles. A was 7 sides, so we did 7 minus 2 times 180, and we got 900. And then we do 900 equals the sum of all of those inside, including the variable y. When you neaten it up, you get 755 plus y. Subtract the 755 over, and y is just 145. In B, we've got a quadrilateral, so it's 360. We just saw that in the warm-up one. So add up the h's, you get 6h. Divide by 6, you get 60. And if you weren't sure that it was 360, you do 4 minus 2 times 180, and that would give you the 360. So here we would have 6 minus 2 times 180, which would give us 720. That's where the 720 is coming from. Add up all of the angles inside, combine like terms, you get 2n plus 494. Subtract the 494 over and divide by 2, and you get 113. In 3, we've got a 5-sided figure. So 5 minus 2 times 180. That would give us the 540. or we had those on our chart from class. Add up all the insides. You get 24x plus 12, subtract the 12 over, divide by 24, you get x is 22. And this one was probably the trickiest. So it's telling us the sum of the interior angles. We have to find the n. So we've got n minus 2 times 180 should equal 1080. Then there's two ways you can solve it. The first way, divide that 180 out of there, then add the 2 over, you get n equals 8. The other way, we could have distributed the 180, so you get 180n minus 360 equals 1080. Add the 360 over, and you get 180n is equal to 1440. And then you would divide the 180 over, and that would also give you n equals 8. So you could do either of those two methods when going through to solve. The setup would have been the same in either case. All right, we'll be on page 63 to start out today. Today is the last day of new material for this unit. And we're going to work with exterior angles of polygons. The sum of the measure of the exterior angles in a convex polygon, so one where it doesn't jut inward, with one exterior angle each vertex is 360 degrees. And that's it. That's always going to be true. It doesn't matter how many sides you have, the exterior angles will always add up to 360. Doesn't change. When you change the figure, the exterior angles will always add to 360. So what is an exterior angle? So you can get it visually. Basically, if you were to extend one of the sides, it creates, when you extend it, that creates the exterior angle. The exterior angle is supplementary with the interior angle because they're two angles on a line that are adding to 180 together. And you could extend it, you have two options for how you extend it. So like this angle 3 here, we extend it this way. You could have also done the exterior angle and done that one. They would end up being vertical, the two different exterior angles, so they're both the same. So it doesn't matter which way you extend to get the exterior angle. You just extend one of the sides and that creates the exterior angle. So something we know here is angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 would be equal to 360 because they are the sum of the exterior angles. The exterior angles are always going to add to 360 in any size polygon. So, to drive home that idea, the exterior angles of a triangle, they will add to 360 degrees. Exterior angles of a pentagon, so 5 sides, add to 360 degrees. The sum of the exterior angles of a heptagon, which is 7 sides, they add to 360 degrees. The sum of the exterior angles of an octagon, which is 8 sides, they add to 360 degrees. And a dodecagon, which is 12 sides, decagon would be 10, dodecagon is 12. Hopefully we can say it all together. They add to 360 degrees. So because they always add to 360, that's a good fact to use when trying to find angles in a polygon because you're starting from the same thing always. All right, if we go down to the bottom, we have some blanks we're going to fill in. An equilateral polygon is one who has all sides congruent. So lats, like your lats on your body, are like your muscles on your sides. So equilateral means equal sides in a polygon. If a polygon has all angles congruent, we call it equiangular, or sometimes equiangular, depending how the person pronounces it. That just means all the angles are equal. Now, if it has both of those things, and this is the term we'll see the most, is a regular polygon. So a regular polygon just means all the interior angles and all the sides are congruent. Now, if each of the interior angles are congruent, then that means each of the exterior angles will also be congruent to each other because they are going to be supplementary. Now, what I mean by that is the exterior and interior aren't the same, but if you compare the exteriors to each of the other exteriors, they'll match. So if we want to find the measure of each exterior angle in a polygon, we're going to round to the nearest tenth if we need to. Well, just take what you start with in degrees, 360, divided by our number of sides, and that's going to give us one angle. So we would get 45 degrees. Now notice our setup here. We did 360. This was the number of sides. And this told us one exterior angle in the regular polygon. And that's what we were looking for. So the next one we'll do 360 divided by 15. If we punch that in the calculator, we'll get 24 degrees. So 360 degrees for the sum of the exteriors divided by 15 sides gives us 24 degrees for one exterior angle. And then if we do it once more, 360 divided by the 13 sides, that will end up giving us to the nearest 10th 27.7 degrees. So doing the sum of the exterior, so 360, divided by the number of sides, that will give us one exterior angle. Because if it's a regular polygon, they will all be the same. All right, on the next page in 7, we're going to do A and B together, and then we're going to let you try C and D and input your answers on the video. So find the number of sides of a regular polygon whose exterior angles each measure 10. Well, let's go back here. We know it's 360 over the number of sides is equal to one exterior angle. So it's 360 over the number of sides. Well, we don't know the number of sides. Let's call it n, is equal to one exterior angle, which is what they're telling us in the question, so 10. We can stick the 10 over 1, and whenever you have two fractions separated by an equal sign, we can cross multiply. Really what you're doing is you're undoing both divisions at the same time. So n times 10 will give us 10n equals 1 times 360 is 360. When you cross multiply, you shouldn't have the fractions anymore. Opposite of multiplying by 10 is dividing by 10. So we get n is equal to 36 sides. We'll do B again together. So 360, because that's the sum of the exteriors. We don't know the number of sides to divide by, but that should give us one exterior angle, which is 36. We'll put the 36 over 1 and we'll cross multiply. 1 times 360 is 360. 36 times n is 36n. We'll divide both sides by 36, and that'll give us 10 sides for n in this case. So I'd like you to take a second and pause the video. Again, these are representing a single exterior angle. We want to find the number of sides. So if you could pause the video, solve each of those, and then when you hit play again, questions will pop up for you to input your answers for each of those. So go ahead and pause the video now. All right, so in C, we should have had 360 over n equals 72. Put it over 1. Cross multiply, you get 360 equals 72n. Divide by 72, and you get n is 5 sides. Over here, we should have had 360 over n is equal to 4. Put it over 1. That's 360 equals 4n. Divide by 4, and you'll get 90 sides for n. So it's the same setup as we had for A and B, so hopefully we were in good shape with those. All right, well now we want to find the measure of one interior angle. Well, I'm just going to draw a random polygon. Maybe I'll draw a hexagon, so we can see the relationship between an interior and an exterior angle. In an exterior angle, you just extend one of the sides to get the exterior angle. Well, notice the interior and the exterior are on a line next to each other. So angles on a line we know add to 180. So we know our interior plus our exterior should add to 180. So if we can find our exterior, we can use that fact to find one interior. So let's do 360 divided by our number of sides, 8 because we have an octagon, and that's going to give us one exterior angle. Well, 360 divided by 8 is going to give us 45. So something that we know is that this angle out here is 45. Well, if we want to find the interior angle, we can just say, okay, x plus 45 we know has to equal 180. Subtract the 45 over, and therefore x, which is what we called our interior angle, would be 135 degrees. Now, I should specify that I drew a hexagon to start out. Really, we just cared about some general exterior angle there. Okay, so for some polygon. So in this decagon here, all right, we got some polygon. Let's extend it to make the exterior angle. So we want to find this one exterior angle, and then we'll use it to find the interior angle. So we always start with 360 for our exterior, divided by our number of sides. Decagon is 10. And that's going to tell us one exterior angle. So that'll give us 36 degrees for the exterior angle. Well, let's pick a variable for the interior. They're angles on a line, so they should add to 180. So x plus 36 should equal 180. We'll subtract the 36. And therefore, x should equal 144 degrees for the interior angle. All right, moving on to page 66, we're going to work inside back to sides. So we have what one interior angle is, and we want to find how many sides there are. Now, we saw in the homework last night that you could, if you knew the sum of the interior angles, you could work with n minus 2 times 180. But we don't know the sum, we just know 1. So if you only know one interior angle, it's easier to move to the exterior. So again, let's just draw like a random picture of part of a polygon. Let's extend that side to make an exterior angle. 162 is the interior. So now let's call x the exterior angle. So we know 162 plus x should equal 180 because they're angles on a line. Subtract the 162 over, and we'll get that x equals 18 for the exterior angle. Well, now we can do like we did at the start of the lesson. We'll do 360 divided by the number of sides, which we don't know, we'll call n, equals our one exterior angle, which is 18. We'll put that over 1 and we'll cross multiply, which will give us 360 equals 18n. We'll divide both sides by 18, and we'll get n is equal to 20. 20 represented our number of sides that is in the original polygon. Now notice all this stuff we're doing is only true of regular polygons, being able to just do 360 divided by the number of sides. That's the most common ones you look at. But it only works because all the exterior angles would be the same since it's a regular polygon. All right, let's see if we can follow the same process here. Here's a random polygon. Let's draw on our exterior angle. The interior is 140. Let's call that x. We can set up 140 plus x is equal to 180 because angles on a line have to add to 180. We'll subtract 140 on both sides. That'll give us x equals 40 for the exterior. So now we'll do 360 divided by the number of sides, n, which we don't know, is equal to one exterior angle, which is 40, over 1. And let's cross multiply. 40n equals 360. Divide both sides by 40. We'll just get that n is equal to 9. Because the zeros, imagine dividing them both by 10, so that's just 36 over 4. 36 over 4 is 9 sides. Moving down to the bottom on 66, they don't tell us it's a regular polygon, but notice we have all the markings on the sides. All those markings are showing us the sides are the same. Well, this is a hexagon. There's 6 congruent sides. So we're working with an exterior angle there. So we can do 360 divided by our number of sides, 6. And this is going to tell us what one exterior angle is. Well, the way to do this in your head is you ignore the 0. 36 divided by 6 is 6, and then tack the 0 back on, so that gives us 60. So one exterior angle is 60, and we've also represented that as 6x. So this should equal 60. We'll divide both sides by 6, and we just get 10 equals x. All right, last one for this video. If we look at number 11 on page 67, one thing to note is that this is not a regular polygon. All the sides and angles are not stated to be the same. So we have to go back to what we did yesterday. We're given interior angles. It's a 4-sided figure. So we can do our n minus 2 times 180 to see what's the sum of those interior angles. So that would be 4 minus 2 times 180, which is 2 times 180, which would give us 360. And you might know that from the fact that this could be split into 2 triangles. So 2 times 180, if each triangle is 180, would give us 360. So let's set up an equation. Our interior angle should add to 360. We'll just add up those 4. So on the right, we can combine like terms. 8x and 1x is 9x. Plus 7x is 16x. Plus 4x is 20x. Our constants, 5 and 30 is 35. And another 5 would give us 40. So plus 40 on the end. We'll subtract the 40 over. And that'll give us 320 equals 20x. Divide both sides by 20. Again, the zeros, you can think of it as divide them both by 10, the zeros go away, and 32 divided by 2 is 16, so x is just equal to 16. Like in everything this year, go back, look at the original question. Okay, x is all we wanted to find, so we're done. Sometimes they'll want us to sub back in. All right, that's it for today's video. Remember to have your homework turned in by 5 a.m. tomorrow on Schoology, and also have your problem set turned in by 5 a.m. Do not be late with that problem set. Get it in on time. Have a great rest of your day.